Hello, in this video, we will be checking how to find if two given input strings are a valid anagram or not. We will be building a solution in JavaScript and also compute the time complexity and space complexity of the solution that we will be building here. Before jumping into the solution aspect of it, let us first try to understand what is a valid anagram. The length of the two strings are equal and the number of occurrences of the alphabets in both the strings is also equal. To elaborate more with an example, let us see this string called as anagram. This string along with another string which reads something like NAGARAM, both of these strings form a valid anagram. Now let us understand why. If you see A is occurring here 1, 2, 3 times. A is appearing here 1, 2, 3 times. N is appearing in this string once. N is also appearing in this string once. A is already counted with 3 repetitions. G is also appearing once in both the strings. R is also appearing once. A we already counted, and M is also appearing once in both the strings. So the number of characters is equal and the count equal. This forms a valid anagram pair. Now let us see when we cannot form a valid anagram. Let's see, for example, this string. We have R here, we have R here. Both strings have one count of R. We have A here, we have A here. Both strings have valid count of A, which is 1, which is equal. And we have T here. There is no T in this one. So as soon as we encounter something that is not there in the second string, we can safely say that this is not going to be a valid anagram because the characters have to repeat in both the strings and the occurrence of those characters also has to match. So that's pretty much in terms of the problem statement. Now in terms of implementation of how to find whether two strings are anagrams or not, what we can do is first check their length. So this is 1, 2, 3, 4, 5, 6, 7. This is also count of 7. 7 equals 7. So we can try to check the next criteria. If at this point the length itself was not equal, then we could just have said that this is not going to be a valid anagram and just return false. Next step is that we will keep track using a hash table, and this hash table will keep track of the character occurrences between these two strings. So let's say this is our string S and this is our string T. We will first check in string S. So we have A here. As soon as we detect something which is there in A, what we will do is we will increment a counter in this hash table. So we will say, okay, we have one occurrence of A. Then we will immediately go to this string, and then we will also check the first element in this string. So we checked A, which is the first element in this string. We checked N, which is the first character in the second string. The character in the first string, we will increment the counter in the hash table. So that's what we did here. As soon as we found A, we incremented the counter and we said this is 1 now. If you find something in this string, then you will reduce the counter. So we will go through both the strings in a sequential order, one by one character at a time. We saw A, we incremented the counter here, it became 1. We were starting with 0, now it became -1. We go to the next iteration, we see N here, we come here, as soon as we see N, we increment the counter. You come to A, you see the counter is 1, you reduce the counter, and the counter will now become 1 minus 1, which is 0. It got reset. Now again go back to the first string. You see A here, you increment the counter again, 0 plus 1 becomes 1. We go to this other string, we see G here, you see that G has a counter of 0 currently, so this becomes -1. Then you go back to this one, you see G here, from -1 the counter becomes 0 again. You go here, you reduce the counter again to 0, so this becomes 0 now. Next you come back to this string, you see R here, you increment the counter from 0 to 1, this has a counter. Then you go back to this one, you again reduce the counter to 0 now. Next you go here, you see A, you increment the counter again by 1. You go here, you see A again, you go here, you see A again, you reduce the counter again, and counter becomes 0 again. And then you come here, you see M, you increase the counter by 1, so now counter becomes 1. You go here, you reduce the counter again, the counter becomes 0. So in the end, we can see that after we have iterated all the characters in both the strings, this is the count that is left of each character that we had. And now we go through all these counters, and if all the counters are 0, that means the length in both the strings of these characters is equal, because in one we incremented a counter, in the second we decremented a counter. Now we will jump into the code aspect of it. Hash table equivalent, I will be using a map, and I will say something like this: let map is equal to new map, and this is going to be keeping track of a character count. Now first thing that we said is we will be checking the length of both the strings. If they don't match, it cannot be possibly an anagram. So I will say if s.length is not equal to t.length, then I will just return false. These are my two input strings that we discussed here, string s and string t. And in the end, if everything goes fine, I will just return true. Now what we will do is we will iterate through both the strings that we have received, and something like this: I is equal to 0, I is less than s dot length, I plus plus. I can safely choose either s or t here because both of them are going to have equal length because they have passed this validation check. And then what I will do is something like this: I will increment with the first string the counter, and I will decrement the counter with the second string. So I will say map dot set whatever character that I have, which is s of I, and I will get the counter, which is going to be my current counter, and then increment it. If there is no counter yet, I will default it to 0. So I will say something like this: map dot get s of I. You either use this or you use a 0, and then to that value, whichever you get, you just increment it by 1, because with the first string we increment, with the second string we decrement. And what we will do here is that with the second string, which is going to be t, I will just get the element and I will decrement the element. So the first string we increment, that is this part of incrementing, and with the second we decrement the character count in the hash table. And that's pretty much it in terms of the tracking purpose through the entire string. Then at the end we will check this counters, and if all the counters are 0, that means both of them are valid anagrams. So what I will do is I will iterate through the map now. We just go through the values of the map that we have here, key and values, and all the values have to be 0. And if they are not 0, then we will just say this is not a valid anagram. In terms of time complexity of this solution, it will be big O of n because we iterate through both the strings towards the end, and n being the worst case scenario wherein we have a very huge length for both the strings. So it will be big O of n plus big O of n, which is going to be big O of n itself. And in terms of the space complexity, it's going to be big O of 1. Reason being that in terms of tracking purposes, we are just using this map, and as we track, we are going to be tracking strings, and in terms of characters you can have max 26 characters. That's why the space is going to be constant, because then the value is just going to get incremented or decremented depending on the values that are getting modified here, but otherwise it's constant space. So that's why the space complexity is also big of 1. And that's pretty much it in terms of implementation. Thank you for watching. Please like and subscribe.